let's have another throwback to geometry. Hello, trig unit. Okay, so I'm going to switch colors here. If we're looking at the 45, 45, 90 right triangle, okay, we know that it is a right angle, which means that the two base angles must be, complementary. Well, not necessarily, well, okay, rewind. So the two base angles have to add up to 90, which means that they are 45, 45, because it's isosceles. Well, back in the day, aka last year, we said that these would be x to find what the relationship was. And then your geometry teacher most likely showed you that this one's going to be x rad 2. It is whatever the side is, the base side, and the hypotenuse is that times rad 2. That was the relationship. Okay, well, for a 30, 60, 90 triangle, the leg across from 30 degrees was the shortest. And we saw that the hypotenuse was double the shortest leg. Okay, reminder, the leg across from the smallest angle is always the shortest. Okay, and then the leg across from 60 degrees was the shortest leg times rad 3. Okay, so if we look at the chart and we're asked to work backwards. Okay, well, let's do this, guy. If I know that my hypotenuse, we'll just call that example 1. If I know that my hypotenuse is 8, and I need to find the short leg, the leg that's across from the 30, then I'm going to say that 8 is equal to 2x, x being my shortest leg, because I know that relationship with my 30, 60, 90 triangle. And then automatically, if I divide by 2, x is 4. So my shortest leg is going to be 4. Okay, what would my middle leg be? It would be that short leg times rad 3. Nice. Okay, so let's do the top one for example 2. If I know that my middle leg given is 5 rad 3, and that is equivalent to x rad 3, because that's the relationship with the sides, then we can say that x is 5. My short leg is 5. And then the hypotenuse is twice that short leg, so it's 10. Okay, well, let's go down to the very bottom. If the hypotenuse is 1, if my hypotenuse is 1, okay, so that's 2x. That means that the short leg is going to be 1/2. All right, so the short leg then is 1/2. The middle leg would be 1/2 times rad 3, or more commonly written as rad 3 over 2. Okay, so that's if the hypotenuse is 1. Nice. Well, let's try chart B with the 45, 45, 90. Okay, let's start with the hypotenuse. So we'll do example 1. Okay, if my hypotenuse is given as 13 rad 2, and I know that in my 45, 45, 90 special right triangle, the relationship is x rad 2. That means that the legs are 13 units, and it's an isosceles triangle, so the legs are the same measurement. Okay, let's do the top one for example 2. I'll stay consistent. So if I'm told that 4 is one of the legs and that's x, okay, that means the other leg is 4 and the hypotenuse is 4 rad 2. Okay, so let's go to something similar that we did with the 30, 60, 90. And if my hypotenuse is 1 and the relationship is x rad 2, well, that means that x is 1 over rad 2. But I can't leave a radical in the denominator. It's not mathematically acceptable. So that means that x is rad 2 over 2. Interesting. Okay, so when we have a hypotenuse with a length of 1, then its legs are rad 2 over 2. Well, how does this relate to the unit circle? Wait, the unit? The unit circle 1. 1. All right, let's go back to our unit circle and see how exactly does this relate to our fantastic unit circle that we love so much. If I'm a unit circle, that means that the radius is 1. Okay, well, if I am a radius of 1, okay, and you guys don't have to draw this in. I'm just going to draw it in for us to see right now. Oh, sorry, 0. Okay, and I draw a right triangle. That means that this is 45 degrees. This is 90 degrees. And then this is 45 degrees. Okay, so from what we just saw, and you guys can flip back and forth a little bit easier than me, sorry. If for 45, 45, 90, its hypotenuse is 1, which is what the unit circle gives us because the radius is 1, then the legs are rad 2 over 2. So that means that this leg is rad 2 over 2. Our hypotenuse is 1, and this leg is rad 2 over 2. Well, what does that mean to the coordinate right here? What does that mean? If I travel rad 2 over 2 units on the x-axis, and then I'd go up rad 2 over 2 units, that means that the coordinate for my 45 degree angle rotation is going to be rad 2 over 2. That is awesome. Okay, well, let's see what that means for the 30. Okay, and I'm going to have a ton of colors right now. You guys stick with me. If I am at 30, okay, we have a leg right here. We've got our radius of 1. This is 30. Okay, well, going back to our chart, if the hypotenuse is 1, so our radius is 1 on the unit circle, our short leg is 1/2. Our middle or longer leg, we'll say, is rad 3 over 2. Okay, so then the short leg across from 30 is 1/2. And that means this is 60 degrees. So this is rad 3 over 2. So then I would travel rad 3 over 2 units on the x-axis. I would go up a 1/2 a unit to get to this coordinate. All because of my special right triangles. How freaking fantastic is this? This is so cool. Okay, so the last one then is going to be the 60. Again, more colors. Live in a colorful world. It's way more fun. Okay, so we have our leg, our hypotenuse, which we know is 1 because it is the unit circle. Okay, so if our hypotenuse is 1, we know that this, oh, hello, that my marker doesn't want to work. Ah! Okay, am I green? Let's be green. Okay, so we know that this is 60, which means that this angle is 30 because this is a right triangle, which I forgot to draw on the blue. Sorry, that's, how dare I? There we go. Okay, so going back, if we know, because of the relationships with our right triangles, if the hypotenuse is 1, so our radius, it's so cool, then the side across from rad 3 over 2, or from 60 is rad 3 over 2. The side across from 30 is 1/2. So on the triangle, we know that the side across from 30 is going to be 1/2. The side across from 60 is rad 3 over 2. So if I travel 1/2 units, yeah, on the x-axis, and I go up rad 3 over 2, that is the coordinate. How awesome is that? So that's where the coordinates come from. Okay, well, we have a big unit circle, yeah? And we know that this is the positive x-axis that we're dealing with, as is the y. Okay, so if I were to look at the second quadrant, okay, let's write that in as a reminder. This is quadrant 1. This is quadrant 2. It's counterclockwise, as if I were rotating with a positive degree measurement. Quadrant 3 and quadrant 4. Okay, so if I'm in the second quadrant, if I look at this coordinate, here, let's make it bigger. Maybe not. There we go. How far is 150 degrees from 180? What's their separation? Oh, it's 30 degrees right here. Okay, so it's going to have the same coordinates as the 30 degree because this would be a 30 degree right triangle, 30, 60, 90. So across from 30 is 1/2. Across from 60 is rad 3/2, but we are in the second quadrant, so I would travel a negative rad 3/2 units on the x-axis, and I would go up a positive 1/2 unit. Okay, that all because of our special right triangle relationships. Well, for this coordinate, this is, how far, I should say, is that ray from 180? What's the space between 135 and 180? It is 45 degrees. Do you see why I use the colors now? So if I drop this down for the right triangle, it becomes a 45, 45, 90, which we saw means this is rad 2/2, all because of the triangles that we saw on the previous page, and this is negative rad 2/2. Negative, why? Because you're on the negative piece of the x-axis. So we would say that I would travel a negative rad 2/2 units and then a positive rad 2/2 up to get to that coordinate. I'm sure you're noticing the pattern, but how far is 120 from 180? Yep, it is 60. So this is a 60 degree angle right there. Drop down the altitude to create that right triangle, and this is 30. Across from 30, we know, is the 1/2. Oh, what? Yes. And then across from the 60 is the rad 3/2, but it is a negative 1/2. So it's negative 1/2 and a positive rad 3/2. If we travel to the third quadrant, how far is 210 from 180? Yep, it is 30 degrees apart. So if I were looking for this coordinate, across from 30 is 1/2. This would be rad 3/2, still negative, but oh yeah, very good. I'm going down a negative also. So I would travel negative rad 3/2 and down a negative 1/2. Notice, with our 30 degree triangles in quadrants 1, 2, and 3, their x and y coordinates are the same, but the signs change depending on the quadrant. Very good. So if I'm in the fourth quadrant, and this is 30 degrees away, 330 and 360, 30 degrees away, we can already say that the x-coordinate is going to be rad 3/2 because of the relation with the special right triangles as far as 30 across from 30 is 1/2, and then this would be rad 3/2. Good. But which one's going to be negative? Ah, yes, it's going to be the y, because we travel along the positive x-axis and go down the negative y-axis. Good, you guys. Okay, so then 225, how far is that from 180? And that is 45 degrees, which means that we are going to have a coordinate at, let's stay consistent, I'm going to draw this, at rad 2/2, rad 2/2, because those are the legs of that triangle, and they are both negative. So if we go to the fourth quadrant, are you having fun? Come on, the unit circle is so rad. This is 45 degrees. Drawing that triangle. Okay, so we have rad 2/2, again, because those are the legs. And the y is negative in the fourth quadrant. So awesome. And then last but not least, how far is 240 from 180? And yes, that is 60 degrees. It's my green color. And then if I were to drop that down to create that right triangle, we know that this is going to be 1/2 because the x portion is across from the 30. And then the y coordinate is going to be rad 3/2, and they are both negative. Hopefully you're seeing these patterns. It's really beautiful. Okay, so 300, I know you think I'm crazy, is 60 degrees away from 360. So again, we would create that 30, 60, 90 right triangle. And then the x coordinate would be 1/2, and the y would be a negative rad 3/2. There are some beautiful patterns. Okay, so if I'm going to make this a little bit smaller, if we look at just the first quadrant, the x coordinates go rad 3/2, rad 2/2, 1/2. So all our denominators that we can see here are 2, regardless of what quadrant we're in. But the numerators from the x perspective go 3, 2, 1. The numerators for the y coordinates go 1, 2, 3. So as you're starting to memorize this unit circle, start looking for those patterns. In the first quadrant, everything's positive. In the second quadrant, x is negative. In the third quadrant, x and y are negative. In the fourth quadrant, only the y, which makes sense. We've been graphing forever. You guys know as you travel around these quadrants, around the origin, that's what happens with our x and y's because of where we're at with the axes. The last thing that I need to fill in is if I'm at 0 degrees, I've traveled out 1 unit to this coordinate, right? But then I don't go up or down. So then I am at 1, 0. Sorry, I didn't like the way that looked. 1, 0. If I rotate to 90 degrees, that means that I have gone, let's see if I can do a straight line. I know. Oh, yep, didn't even start right. Awesome. Nothing has changed with me, guys. Oh, child. Yeah, it's 7:45 in the morning and he wanted a ring pop. Okay, anyway, so I don't go left or right, so it would be 0, but I do go up 1 unit. Okay, for 180 degrees rotation, we are on the negative piece of the x-axis. So I go out -1 units, and then I don't go up or down. And then last but not least, if I rotate to 270, I don't go right and left, but I do go down to a -1. And then if you keep rotating over to 360, you're back where you started at 1, 0. Ladies and gentlemen, the coordinates of the unit circle. Ah, it's so amazing. You do need to start memorizing this. Okay, again, for our skill 3 notes, I'll talk a little bit more about it and a little bit more of the tricks and stuff. Sweet.